And let's go ahead and set up the pop network, and then we can do further adjusting here. So we will plug this inside a pop net. Let's step inside, and for our particle source, let's disable guide. Emission type should be all points. And by default, if I go to the attributes tab, we are inheriting the velocity, and the points do have velocity. So if I go to the result of the blast and turn on the point trail display, we see that all of the points have velocities, and especially when our hand is reaching for the snow. Let's maybe preview this in our time shift instead. Over here we can see all of these vectors now, so all of our velocities from our initial grain simulation, and especially when the hand starts to move, we have all of this velocity information that we want to transfer over to our particles. So with this being said, let's go back to the PopNet, and if I step back inside, we have the inherit velocity. So we are going to have this velocity transfer by default. Let's press play and see what we get. So as I play this, our points immediately start to rise up for some reason, and this is not the intended behavior whatsoever. So let's take a look at what's happening here. If I go back and go to my blast node and preview, or rather turn on the point trail display, we can see that these points already have some velocity. Now nothing is happening on the first frame of our simulation with the grain, so why is this happening? If I go back to where we have our grain simulation, so where we did our file cache, and let's also get rid of this GL sphere display. Let's do an attribute delete and delete this. I think it's the detail attribute, so sphere points, and this is what's rendering them as spheres. So if we get rid of this and just preview them as points, we see that on the first frame right away we have some velocities on the points, and if I go forward a few frames, we no longer have this velocity attribute. And this is because on the first frame, when our particles are getting initiated, they need a few frames until they actually settle. So this isn't really noticeable on our render when we create the volumes, but this is something that does happen. And on the very first frame, we do have velocity, and we can see that already by the second frame, our velocities are even smaller, and on the third frame, they are basically no longer here. Maybe we can still see a little bit of velocities on some of these points, but if I go forward one more frame, we barely have anything, and by frame 6 or 7, I believe, they settle entirely. So to fix our problem, what we have to do is just specify that for the first frame of our simulation, let's just look 7 frames after. And we can do this very easily. If I go to this time shift over here, instead of clamping this at the first frame over here, I will remove this expression with Ctrl-Shift-Click, and I will say that the start frame is going to be frame number 7. So now our points will be frozen until frame 57, and only from frame 58 they will start to move again. And if I go now to my blast node and also preview the velocities here, we probably still have a little bit of velocities, but this shouldn't be too bad. This won't affect our simulation that much because we are going to add our pyro velocity to the points anyway. So if I go back and reset the simulation, we are going to still have some movement, but it won't be that much. So if I press play, we can see now that they're basically more static. So I can preview this, and we can see that only when our hand reaches the ground, we have some of these impact here from the hand animation. So as I play this now, roughly at frame 72, so this is accounting with the 50 frame pre-roll, this is when the hand reaches the ground, and if I play this further, we should see even more velocities coming from where the hand starts to swipe on the ground. So let's press play, and we can see this here. Maybe let's turn to pixel display, and let's also append a color swap so we can see this maybe better like this, and go back to my dark display. So this is a little bit hard to tell because we are not killing the particles, we have a little bit too many, but what I'm trying to say here is that we are inheriting the velocities from the hand animation. So let's go ahead and set up our volume advection, and let's go to our pyrovel. Let's Control C, and we will bring this in our popnet. We will do an advect by volumes, and we are going to point the swap path to our pyro velocity. Field name will be vel, and for advection type we will want to use update velocity. So by using the update velocities, this will also allow us to blend the velocity with our existing velocity that we are inheriting from the grain. And to control this further, we are also going to use the expression here, and we are going to scale this velocity scale from the value it already is. So 1, let's say vel scale multiplies equal, and we are going to blend this based on our age. So let's do a fit, and in between parentheses we will say age, and from an age value of 0.1 or maybe 0.2 to an age of 0.4, let's blend this from 0 to 1. So after a particle is born, for roughly half a second, it won't be affected by this velocity field, and this will give the particle a chance to move in the beginning based on the velocity from the hand animation. And we are going to see this in action more clearly in a second here. Let's also optimize the setup overall a little bit, so we can go to the pop source, and we don't want these to last forever. Let's start with a life expectancy of 1.2 and life variance of 0.3. And also we can remove any particles that are stepping outside of the field of view of our camera. So we can do a pop kill for this, and we are going to use the bounding option here, and let's use a bounding object, and we are going to use the camera frustum object that we have. So let's go up, and over here at the top where we have our camera frustum, we can go ahead and grab this, so Control C, and let's bring this in as our object. So let's point the saw path to this, and we have to hit enable here, and we want the invert effect to be, so by default it will kill anything that's inside, and we want it on the outside. So let's hit this invert, and we don't need to display the guide. And now if I play the simulation, we can see immediately that for a few frames here, the particles stay where they are, and only after a while they get advected by the smoke. Now this is also because the smoke starts from over here, and it needs a second to get to the other side as well, but also because of this expression that we provided here. So let's just play the simulation and see the result that we get, and I can tell that this is already looking pretty nice. Let's press D, and let's set this back to light. All right, and we are interested in what's gonna happen when the hand reaches the ground. All right, so it's a little bit hard to tell. Let's move forward with our setup